All right, so we're going to look into more of u substitution. And we did a sum with trig yesterday, but we're going to look at some other trig ones as well. So I want you to first remember and see if you can do the integrals of all those trig things, because that's going to be a must. So let's see if you remember. What is the integral of sine? Or in other words, what's the integral of cosine? Or in other words, who has a derivative of cosine is sine. And hopefully these are easily filled out. Remember, that's important for you to recognize these derivatives. In other words, secant tangent is the derivative of somebody, because you have to be able to recognize that. And if you don't know these integrals that you should just do in your head, that's going to be a problem for you as we get into more difficult trig integrals. So in the same way, the difference is why is example 1 harder than, say, this problem? Well, it's because the inner derivative, it's a composition. So you have an inner derivative. What you're taking, this argument here, the sine of what, that thing doesn't have just a derivative of 1, so that means you have to do trig sub. Now it's going to resemble u sub. It's going to resemble this, but there's a little more to it. So another good choice for you, we talked about yesterday that, oh, well, a good choice for you was what's being raised to the power. Well, the problem is I don't see anything being raised to the power. So really, the reason why we picked u yesterday was because it was the inner function. The power was the outer function, so you chose the inner function. Well, it's the same thing with the trig. You're going to let u be your inner function. So when you see trig, am I saying every time do this? No, but I'm saying that one good choice for you is, of course, the inner function. That's always true. That statement's always true. But when you see trig, a good choice for you is the argument. Does that have an E in it? I don't think so. The argument of a trig function. Now here's the good news. Once you have established your u, you're going to see that I am doing the exact same steps as yesterday. So I probably can go a smidge faster than yesterday because you've done it, you've seen it, you have the steps. So you're like, all right, let u be the inner function. Du is going to be 6 dx. And you're like, all right, let's do the sub. So that would be the sine of u. What is dx? Well, using this statement, that would be du over 6. So you kind of have gotten in that habit. And then you're just integrating. Sine of u du is just like sine of x dx. I just have u in it. So I'd have 1/6. This would be negative cosine of u plus c. And then my last step, I'm going to simplify, or, kind of write pretty and resubstitute back in what u is. And so my final answer would look like that. And there you go. I could always take the derivative of that and make sure I get back to my question, and I do. Let's try example 2. What do you think a good u would be? You guessed it. 5 minus 2x. I see trig. I think maybe the argument. Du is negative 2 dx. So what's my sub? I have secant of u, tangent of u. I've got to also substitute for dx. Looking right here, that's going to be du over negative 1/2. Here's where your memorization comes in, because you go, oh, that's a product. There is no product rule. Yes, that's true. There is no product rule, but secant tangent is the derivative of somebody. I already know how to integrate that. So -1/2 secant of u plus c. Now let's plug back in. -1/2 secant of 5 minus 2x plus c. And there she goes. So not so bad, not so bad. Now example 3, you go, okay, well, wait a minute. I see a power because really what is being written here? I mean, I could technically write this as secant of 3x squared, all of that squared, because that's what that squared is, times x dx. So you go, well, which one do I do? Do I do secant? Because yesterday you said if I saw a power, I should let your u be what I'm being raised to the power. Well, that's where the trig gets difficult, because I can't say, oh, every time, yeah, let it be what you're raising to the power, or every time let it just be the argument. That's where the practice comes in, and recognizing, here's the deal. If I let u be all of this, do you see that I would have to, my derivative would be secant tangent, and that's going to get really complicated. So I can try something, but if it makes it more complicated, it's probably not the correct u. So in this case, I'm gonna try and go, you know what? Let me keep my u to be the argument of 3x squared. So let's let u be this. So du would be 6x dx. Now look at what I have. I still might think of writing it this way because I always look to simplify nicely, and I look at the x's that are in this statement and in my question, and I go, oh, this is just lovely. Secant squared of u, x dx. I'm not going to solve for dx here. I'm going to solve for x dx. And if I solve for x dx, that would be du over 6. And there's my u substitution. And it's a simple one. See, that's the point, is u substitution should get you down to something simple that you can integrate very quickly. Secant squared is the derivative of tangent. So I have this. And so my final answer is 1/6 tangent of 3x squared plus c. And there you go. Notice that with trig, the arguments never change. A big mistake that I see on answers is that, in here I just see x instead of 3x squared. So notice, see how the argument of your trig function is 3x squared, and the argument, my answer is 3x squared. My argument was 5 minus 2x, and my argument in my answer is 5 minus 2x. So remember that, that your arguments never change. Okay, let's try this next one. I bet you could maybe see it. I could have really given you this one yesterday. Let's see here. I do see a power. I see cosine of 2x. If I bring it to the top, that would be to the -4th sine of 2x dx. Okay, so I'm thinking a smart choice from what we did yesterday. Again, if I did 2x, I still would have something that I wouldn't be able to integrate, because I would still have a sine and a cosine, and that wouldn't help me out. So I am going to, in this one, I'm not going to let it just be the argument. I'm going to let it be all of that, what's being raised to that power. Now, just like yesterday, I can't say that my answer, my derivative, is just negative sine 2x dx. I'm hoping that you remembered the chain rule there. So what do I have? I have the integral of u to the negative fourth sine of 2x dx. Sine of 2x dx. I'm going to substitute for all of that. How would it sub? Well, du over negative 2. So I'm going to have a negative 1/2 in front. Increase the power by 1. Make sure you do an increase. I would have times a 1/3. Don't forget about the negative 1/2 coming along for the ride. Plus c. And then I'm done. So I have 1/6. I would have cosine. You could probably have done this in a lot shorter steps here, but I could write it like this. Yes, most likely they don't write negative exponents, so they could write it like this, which is correct. But what else could they do? Well, you know that if there's trig, you've always got trig identities. So having cosine cubed in the denominator is like having what in the numerator? Well, by trig identities, that's like having secant. So they could technically write the answer like this. So I just want you to be clear that I'm not saying that any of these are incorrect. I'm saying you would have to match your answer choice with what is given. Okay? All right, let's look at example 5. Now, example 5, you go, holy, wait a minute. On example 4, it was pretty easy. Like, how did you know to do cosine of 2x rather than sine of 2x? Well, I'm hoping that you thought, well, this one was being raised to a power of negative 4. Like, it was just kind of, I don't know, it was obvious. That one was the one being raised to the power. Whereas over here, they're both being raised to a power. So how do you figure that out? Okay, well, let's look at it. If I, and maybe you don't want to write this down, just hold for a second, but I want you to see. Let's let your u be secant of 4x. If I let u be secant, do you agree that my derivative would be secant tangent? Of course, times the 4. Well, if you start the substituting, you would have u squared. Now you have tangent cubed. You have 3 tangents. How the heck, like what? How the heck can I do tangent? I would still have, if I tried to solve for tangent of 4x, I'd still have an x in there. Like it's not getting simplified. Like I'm not seeing it. So I'm thinking, all right, well, maybe that's not right. Let's try something else. Let's let your u, let's try the other one. Let's let your u be tangent of 4x. It's being raised to a power as well. And then du would be 4 secant squared of 4x dx. And I go, okay, I'm getting somewhere. Because if this integral is tangent of 4x really cubed secant squared of 4x dx, remember when you do the u sub, it should get to something that is easily integrated. So what I would have would be the integral of u to the third secant squared 4x, but my parentheses in a weird spot right there. I don't know why. It should be there. Not there. So secant squared of 4x dx, look, secant squared of 4x dx. What would, I could replace all of this with du over 4. Well, golly darn, that looks really simple to integrate. Increase the power by 1, divide by the new power, the 1/4 comes along for the ride, and so I get a final answer of 1/16. And then my u was tangent, so tangent to the 4th of 4x plus c. So you just have to play with it. This is your first time through on things. You may not get it correct the first time, and that's okay. But you have to know, okay, if I'm not getting it right the first time, I've got to know that I'm going down the wrong route. That's the problem, is when you fumble around for a long time and you're wasting a lot of time. So I want you to fumble a little bit on example 6 and come back when you think that you had it. This one's real interesting. Well, once again, you kind of go, oh, Miss Pruitt, this is not that hard. I mean, I'm going to let cosecant, I mean, I have something to the 5th, so it's usually the higher power. I mean, not always, but that's a pretty good bet. So, okay, let's let it be cosecant of 8x. So what would my derivative of cosecant of 8x be? All right, let me think. The derivative of cosecant is negative cosecant cotangent, but I can't remember the inner derivative, which is 8, so I would have all of that. Okay, so what do I have? Well, if I start substituting here, just like this, I would have the integral of u to the 5th. Now I have cotangent of 8x. Well, okay, well I can't really solve for just cotangent of 8x. I have a cosecant in there as well. So it's like I need a cosecant for part of the derivative. Look, guys, you have 5 cosecants. So what are you going to do? You're going to borrow one. You're going to go, hold on, cosecant to the 5th, I could write that as cosecant of 8x to the 4th times another cosecant, and then I have, of course, the cotangent. Looking at what I have on my paper right now, in this line, if I simplified, would I not get back to the question? It's like you're borrowing one. You're needing one for the derivative. So now when you substitute, you have u to the 4th. You can substitute for all of this. See that? Cosecant, cotangent, that would be du over negative 8. So you have a negative 1/8 out there, and now you're home free. This part's the easy part. And so my final answer is negative 1/40 cosecant to the 5th of 8x plus c. And that wigs people out. And I think you can see why it wigs people out in that you're like, wait, you started with a 5th. How are you ending with a 5th? And that's the part that people are like, wait a second. And so that borrowing is something that you have to see. All right, last one. Last one, but it's a doozy. Because I know you're not going to like this, but I'm going to do this in 3 ways. Now, I'm not expecting you to do it in 3 ways. So if you're watching this video, just integrate and come back, but I want to make a point on this one. 2 points, actually. One is that there are different ways to do this problem. 2, don't ever underestimate the power of 1. Because really this problem, if I had sine to the 5th, like if I had add that in, you'd go, oh, u is sine. If you had a power of 5 or 3 or 2, it's very easy to see. The power of 1 is sometimes difficult. So let me show you, and yes, I'm going to do this 3 different ways. The first one, I'm going to let my u be sine. So the derivative of sine is cosine. I think you can see the substitution. Sine of x would be u. Cosine of x dx would be du. So how do I integrate u to the 1st? That power of 1 is 1/2 u squared plus c. And I would get an answer of 1/2 sine squared of x, not dx, plus c. So that's looking good, and that's wonderful. And honestly, if I were doing this problem, that's probably what I would see. But somebody else could go, no. I let my u be cosine of x, so that my du was negative sine of x dx. So when I looked at that problem, I just kind of switched them in a way. So I replaced this cosine with u. The sine of x dx, no problem. I just put du and I slapped a negative out there because I would have to solve. Once again, I'm just integrating u to the first, so I'd get negative 1/2 u squared plus c, and I got an answer of negative 1/2 cosine squared of x plus c. I mean, those look very, very different, so which one is right? Well, they both are. Okay, they both are. And you're like, how are those two things the same? Well, you've got identities. Remember, with identities, I could replace sine squared. I mean, it doesn't matter which one I'm going to from one to the other. I could replace sine squared with 1 minus cosine squared. Isn't that true? And what would I have? I would have 1/2 minus 1/2 cosine squared of x plus c. Well, 1/2 plus a c, isn't that just a constant? So that's how I have negative 1/2 cosine squared plus some constant. These constants aren't necessarily the same, but that's how I go from one to the other. Now the third one's a real doozy. Some people use a trig identity from the beginning. And they go, wait a minute. I know, I recognize, and I go, there seems an identity that the sine of 2x is 2 sine x cosine x. Yes? So if I just had sine of x cosine of x, I really could write that as 1/2 of the sine of 2x. So I could rewrite this whole problem of sine of x cosine x as the integral of 1/2 sine of 2x. And if I did that, my u would be 2x, du would be 2 dx. So what would I be integrating? I'll go ahead and pull this 1/2 out just to get him out of the way. I'd have the sine of u, and then when I solved for this dx, I would have another 1/2, so I would have that out there. What's the integral of sine? The integral of sine is negative cosine, so I'd have negative 1/4 cosine of u plus c, so my final answer would look like negative 1/4 cosine of 2x plus c, and that's a correct answer. So you're like, well, la-di-da. How the heck am I supposed to know which one to do? Well, if it's free response, they'll accept any of them. If it's multiple choice, then you're going to look at your answer choices and kind of see what they did. Okay, if worse comes to worse, remember with multiple choice answers, you can always work backwards. I could take the derivative of each one of these things and I would get back to the original question. So I wanted you to see that because I wanted you to see that you and your neighbor on some problems, now I'm not saying every problem, but on some problems, there's more than one correct u that could be correct. And your answers look very different. So obviously, I just wanted you to see that and be aware of that. All right, so keep working on trig u sub. Peace out.